Hi everyone, my name is Amitesh and in this video we're going to solve the Pythagorean theorem. So what does it even mean? I'm going to explain that. So here we have a right triangle, side lengths A, B and hypotenuse C. The Pythagorean theorem tells us a squared plus b squared is c squared. Now we want to find out all the triples A, B and C that solve this equation. Now you might ask, well, isn't this not very interesting? I mean, if I specify two numbers A and B, then you always get a C, right? No matter what A and B are, you'll always get a C. A squared plus b squared is c squared, so C is square root a squared plus b squared. And similarly, if you specify C and B, then so long as c squared minus b squared is a non-negative number, you can find an A that solves that equation. So that's not an interesting question. But what we're interested in is what are called Pythagorean triples. So Pythagorean triples are triples where A, B, and C are integers. Okay, so they're not just any numbers, they are integers, and these are much rarer. So for example, the most famous example of a Pythagorean triple is 3 squared plus 4 squared equals to 5 squared. So 3, 4, and 5, you can check this equation is true. So you have that right triangle with side lengths 3, 4, and 5. On the other hand, you could also have other Pythagorean triples. So here's a cheap way to get one. You could take something like 6 squared plus 8 squared is equal to 10 squared. And all I've done here actually is multiply the first equation by 4, okay, which is 2 squared, and then I got 6 squared plus 8 squared is 10 squared. So that's another Pythagorean triple. We call this what is called a primitive triple. Okay, so primitive because it's kind of the simplest one. You can't divide all the numbers by something to get something simpler like you could for 6 squared plus 8 squared is 10 squared. Now I'm going to show you, watch till the end because I'm going to show you a super cool, this is actually graduate level math. It's a subject called arithmetic geometry. It's a beautiful construction for actually finding out what all the Pythagorean triples are, and it's going to be so elementary. It's explained like for a high schooler basically, or even someone younger than that. So let's get into it. How are we going to find all the integer solutions to a squared plus b squared is c squared? So here's what we're going to do. Number one is we're going to, and I want you to come up with some more examples. Drop me some comments down below. You know, more examples of solutions. I gave you 3, 4, 5. Are there others? There are definitely others. Drop them down below. We're going to find a formula for all of them. So that's how cool this is going to be. So the first thing we're going to do is we're going to define, if we have a squared plus b squared is c squared, where a, b, and c are integers, we can divide the equation on both sides by c squared. Okay, so we're going to get that therefore a squared by c squared plus b squared by c squared is going to equal to 1. So another way of phrasing our question is we're trying to solve, this is a over c squared plus b over c squared is equal to 1. So I'm going to make our equation a equation of something in the plane. Okay, so let's get into that. A over c, b over c. Now here, of course, a over c and b over c are no longer integers. They are rational numbers. They are fractions. Okay, so these are rational numbers. A over c and b over c are going to be rational. So we're interested in what are called rational solutions to this equation, x squared plus y squared is equal to 1. Okay, now, does that equation seem familiar? X squared plus y squared equals to 1. I mean, that looks familiar, right? That is a circle. And that is actually a version of the Pythagorean theorem, that if you take all the points in the xy plane, x comma y, so that x squared plus y squared is equal to 1, that's just going to be x squared plus y squared, the square root of that is just the distance of the point to 0. That's actually the Pythagorean theorem. So if you draw that out, that's going to be a unit circle. Okay, so here we can draw a unit circle in the plane, so I'm just going to get a red marker, and I'm going to show you this in visually, so you have a circle. So for example, if you have a point like x comma y here, x comma y, then if you draw a right triangle, the base is x, the height is y. So because it's a unit circle of radius 1, your x squared plus y squared is going to equal to 1 squared, which is just 1. Okay, so that's going to be, we're trying to find points in the unit circle with rational coordinates. Okay, so the coordinates of those points have to be rational, and that's pretty rare. You know, if you think about, like, for example, cosine theta, sine theta, right? They're going to be the typical point on the unit circle. If you're familiar with trig, if not, don't worry about that. But they're going to generally be irrational numbers. But we can do this beautiful argument, and this is the arithmetic geometry I was telling you about. It's a really beautiful argument. I love it. And it's the following trick, okay? Because you can brute force solve that equation. There are some strategies in number theory, but this is kind of something visual, and humans are more designed to see things visually. So how is this going to go? So what we're going to do is we're going to take the point 1, 0, okay? And we're going to observe the following. Let's draw lines sweeping out the circle, okay, that are starting at 1, 0. So for example, we have this line, we have this line, we have this line. So I'm just drawing all kinds of lines, okay, that are going to sweep out. They're all passing through 1, 0. They're going to sweep out the circle. Now here's the observation. the end point, each of these lines is going to hit the circle in a point, right? Each of these lines. There's only one line that isn't going to do it. And that line is basically the line that is vertical, that is vertically tangent to the circle at 1, 0. Okay, so that line is not going to hit any other point on the circle, but every other line is going to. And if the line has a rational slope, then it's going to cut the circle in a point with rational coordinates. And vice versa, if the point has rational coordinates, it's going to correspond to a rational slope line. Why is that? Well, if a point has rational coordinates, let's say here you have like x comma y, well, what is the definition of the slope of the line that passes through 1, 0 and x comma y? What's the definition? It's a change in y coordinate by the change in x coordinate. So the slope of the line is going to equal to, what is the y coordinate? 0 and y, right? So it's going to be, it doesn't matter which order. So you can say y minus 0 divided by x minus 1. Okay, so the slope of the line is going to be y over x minus 1. So if x and y are going to be rational numbers, this slope is also going to be rational. So we are interested in rational slope lines, and we're going to solve the equation and find out where they intersect the circle and thereby solve the Pythagorean theorem. So let's get into that, okay? And I want you to kind of think about this intuitively and play around with it. You know, pause the video, see if you can work it out, and then watch how I do it, okay? So that's what we're going to do. So this is going to be super cool, okay? You're going to get a formula, okay? That's what I love about this. So how is it going to work? So let's take a slope, okay? Let's take a slope like P over Q, okay? Let's stick with P over Q. What is the equation? This is the point slope form of a line, okay? So this is high school math applied into something really cool and elegant and creative. Okay, so point slope form of a line. Point slope form of a line, it passes through 1, 0, so that's the point, and its slope is going to be some rational number, okay, P over Q. P over Q is the slope. Okay, now if we're trying to visualize this, if the slope is going to be negative, it's going to cut the circle in a point on the upper, above the x-axis. Otherwise, it's going to cut the circle in a point below the x-axis. Okay, so, but we are not going to think about that just yet. We're going to write down what is the point slope form of the line. So it is going to be y minus y1. So take the point. This is x1 and y1. Okay, we can just do the point slope form. So we've got x1 and y1. So then I like to do it. This is the slope. You can call it m if you like. So if you know the point slope form, it's going to be y minus y1 equals to m into x minus x1. So therefore, y minus y1 is going to be 0. Y minus 0 is going to be P over Q times x minus 1. Okay, so that's going to be the equation of the line. It's going to be, therefore, y is going to equal to P over Q times x minus P over Q. Okay, that's going to be the equation of the line that has slope P over Q and passes through 1, 0. Where does this point cut the circle? Well, we have to solve an equation, right? We have to find when these two, the circle and this line, are intersecting. We take the equation of the circle and plug in that equation for the line and try to solve for that. Okay, so that's going to be the next step. So how are we going to do that? So this is really, really cool. This is going to be, we're going to take our equation of our circle, x squared plus y squared equals to 1, plug that in. Okay, y equals P over Q, x minus P over Q. Okay, so we're going to get x squared plus P over Q, x minus P over Q, or P over Q times x minus 1. So we say P over Q x minus 1 squared is equal to 1. Okay? Now we're going to solve for x. Okay, so let's do that. So I'm going to just go through these steps quickly. So solving for x, we're going to get x squared plus p squared by q squared, x squared, minus 2p over qx plus p over q. P squared over q squared. Okay, so this is going to be 2p squared over q squared plus p squared over q squared. Okay, so just kind of making sure I get that right. So we've got that. So that's going to equal to 1. So that's going to be our equation we're going to solve for x. And this is going to be now the quadratic formula. Okay, so it's a quadratic formula. So we want to just write out the coefficients very clearly. So we're going to get 1 plus p squared over q squared times x squared. Okay, minus 2p squared over q squared times x plus p squared over q squared minus 1 is equal to 0. Okay, so that's going to be the equation we're interested in. We need to solve now. Okay, we need to solve for x, so we apply the quadratic formula. Okay, so that's going to be our solutions. Now, here's the thing. One of the solutions, why are there two solutions? Doesn't it cut the circle in the one point? Here's a question for you. Think about that. Drop a comment down below. I'd love to see it. But the other thing is the other solution. So one of the solutions is going to be the one we want. So let's actually just simplify this expression. So here we can just simplify the radical. So I'm just going to do this separately on this side of the board. This is a cool formula. It's a difference of squares formula. Okay, so this comes up all the time. A minus b times a plus b is going to be a squared minus b squared. So here we have 1 plus p squared over q squared times 1 minus p squared over q squared. So we can write that as 4p to the 4, what's inside the square root, plus 4 times a squared minus b squared. So 4 times 1 minus p squared over q squared the whole squared, which is p power 4 over q to the 4. Okay, so here I've used the formula just to kind of be clear. A minus b times a plus b is equal to a squared minus b squared. Okay, so that's the formula I've used. So now we can write this out. So we can subtract off, see something cancels. So you just get a 4 here. Okay, so you just get 4p power 4 times q to the 4 plus 4 minus 4p power 4 by q to the 4. So that's just going to equal to 4. So therefore, the thing inside the square root is pretty nice. So we're just going to get 2p squared over q squared plus or minus the square root of 4, which is just 2, divided by 2 times. Now I can simplify that. I can make a common denominator. 1 plus p squared over q squared is just going to be q squared plus p squared over q squared. Okay, so it's going to be p squared plus q squared over q squared. So that's going to be our answer. We can even simplify this further. So let's do that. So we can now, I'm going to write it out here. We can simplify that. We can make a common denominator up top, sorry. So you get 2p squared plus or minus 2q squared divided by q squared. And then you invert the fraction down the bottom. So that's just going to be equal to, so you're going to get q squared divided by 2 times p squared plus q squared. Okay, so this cancels off. So therefore we get 2p squared plus or minus 2q squared, right? So we're going to get the 2's cancel as well. You can factor out a 2 here. So you're just going to get p squared plus or minus q squared divided by p squared plus q squared. Now this is interesting. One of the solutions here is just going to be 1, because if you take the plus sign, you're dividing it by itself, it's 1. And that corresponds, that was my question to you, that corresponds to the fact the line passed through 1, 0. Okay, so the other point is where we're going to intersect the circle, and that is the point x. That is the point x equals p squared minus q squared by p squared plus q squared. Okay, so now that we've got that down, we know what x is. X is p squared minus q squared by p squared plus q squared. P squared minus q squared by p squared plus q squared. And then we can plug in y into the original equation, right? What was y? We knew the equation of the line. We knew that y was going to equal to p over q times x minus 1. Okay, that was the equation of the line. So you can plug that in. It's going to be p over q times, what is x minus 1? It's going to be p squared minus q squared minus p squared minus q squared divided by p squared plus q squared. Okay, so I'm just kind of simplifying out the fractions quickly. But then, I encourage you, if you're stuck, you can work it out yourself, is more fun. But also you can just watch along and try to understand each step. So p squared minus 2q squared, we're almost done anyway. So it's going to be minus q squared over q, which is minus q times p. So it's going to equal to, we'll get minus 2q squared times p over q. So it's going to be minus 2pq divided by p squared plus q squared. And that is going to be our y coordinate. And you notice that our y coordinate is going to be negative if p and q are both positive. Okay, so if our slope was positive, then we're going to hit a point below the x-axis on the circle. And here we got x equals this. So that's going to be the solution. And these are all the solutions to the Pythagorean theorem that are integer solutions. So I'm just going to finish it off and confirm this. So let's actually just write it out, because this is the most interesting part. We've just solved the Pythagorean theorem, basically. We found out all the values that solve it, which are integers or rational numbers equivalently. So here we're going to get p squared minus q squared divided by p squared plus q squared. And then we're going to get squared plus minus 2pq over p squared plus q squared is equal to 1. Okay, and if we now multiply out by the denominator squared, which is what we did initially to convert into a statement about rational solutions from integer solutions, then we're just going to get p squared minus q squared squared plus 2pq minus 2pq squared is just going to equal to 1. It's just going to equal to p squared plus q squared squared. Okay, so these are going to be all the solutions to the Pythagorean theorem. And if you like, you can sort of say that, okay, with these solutions, you can just say that You can choose the signs of P and Q accordingly, but these are the numbers. So this is A, this is B, this is C. So long as A, B, and C are all non-negative, if you like, they are side lengths of a right triangle. Okay, so you can find out that these are all the side lengths of right triangles, which are integer side lengths, p squared minus q squared minus 2pq and p squared plus q squared. P and q can be any numbers you like, so long as all these side lengths are going to be non-negative, and then you're going to get a right triangle which is a Pythagorean triple basically, as we defined at the beginning. So I want you to play around with this formula. It's my challenge to you. Play around with this formula, come up with some Pythagorean triples, drop a comment down below, and let me know if you have any questions. I love this proof because it's this cool geometric argument. How would you solve it? Like once you sort of see this here, you can sort of see, like try out the binomial theorem. I have a video of the binomial theorem on my channel, check it out. I give different ways of looking at it, but using the binomial theorem, you can sort of cancel off and you can see that this equation is satisfied. If someone tells this to you, you've got the solution, but how do you know these are all the solutions? You don't. But we've proven it in this video using that line method of intersecting with the circle, and we've actually been able to find it out in the first place. Okay, so that's kind of the motivation. That's why math is so creative and beautiful, that these pictures, correspond to these kinds of things. It has nothing to do with the right triangle seemingly, but it's kind of saying something fundamental about right triangles. Thank you so much for watching. I love that you watched this video. I'm super grateful. And please leave a like, subscribe, share. Everyone asked for this, but I'm really trying to help as many people as possible. I want infinite free accessible math education to help students in high school, college, everyone. There's content on my channel for everyone. So check out my channel. Watch relevant videos if you like. There's going to be all kinds of content. Share with friends and family. Help me grow the channel. Spread the word. That would mean so much to me. If you've watched this far, thank you so much for your support. I'm super excited to see you in the next video. Wish you all the best. I hope you love this creative argument as much as I do. And I'm super excited to see you soon. Take care.